For number one, perform the transformation 10931 negative 2 on the unit square. So what we're going to do is multiply this matrix times each point on the unit square to transform it. When we perform those transformations, we actually end up with this parallelogram because this got multiplied by each one of these points. So when we multiply by 0, 0, it stayed where it was. And then we have the other 3 points respectively of how we got this parallelogram. So I want to use that to discuss the determinant because the big idea of today's lesson is the determinant. The determinant of a 2 by 2 matrix is you multiply the diagonals and take the difference. So to find the determinant, AD subtract BC. So I multiply A times D minus B times C. So let's perform that operation on this transformation. So I'm going to put these values into this formula. So notice 109 is multiplied by negative 2, and then it's minus 1 multiplied by 3, because what we're doing is the diagonals. 109, negative 2, minus 1 times 3. And that's how we get our result. Now, when you see our answer, we get negative 221. And this is the most important thing about the area. In order to get the actual area, we use the determinant, but we must take the absolute value. So what does absolute value start with? A, B, S. Now I can go up and steal that calculation. And of course, we just take away the negative, and it's positive 221. So when we go back to our document, the one note that I want to put here is always take the absolute value. Find the area, because the point is we use the determinant to calculate it, but area is a lot like a distance. You can have an area of 0 if there is no area, but you can't really have a negative area. So our response to this question, what is the area of the image? The area is 221 square units. And this is, without a doubt, the most important part of the lesson. Now, one other detail I do want to show you is how we actually use matrices to show graphs and area and things like that. So we're going to go down near the end of our document. This entire document has been posted in Schoology, so you can check your answers and find a lot of notes to figure out what's going on, but I do want to show you one more detail before we stop. So here it says, perform the following transformation on the unit square, sketch the image, find the determinant of the given matrix, and find the area of the image. So I'm going to take this matrix and store it in my calculator as Z. So I store this matrix as Z. Next, I want to store the 4 points on the unit square as A, B, C, and D respectively. So there's my points A, B, C, and D stored in my calculator. Now I can perform this transformation on each point. So we start with z times a, then z times b, and eventually we get to z times d. And there are the points that we're going to plot. So I've given you the points for A through F on the graphs in the document that I put into Schoology. So all we're going to do is go through and actually plot those points. And notice that we still get a parallelogram. It's just shaped really weird. And the idea is, what I want you to do is look at the parallelogram and maybe try to connect what the determinant would be for each of these parallelograms once you plot it. And that's just a quick glance of what's going on for lesson 1.26. And this should prepare you for anything that I might put on the quiz tomorrow.